So part A on this one is asking how many gallons of water were initially in the bucket if we were losing water at a rate of 0.5 gallons per minute, or half a gallon per minute. And after 6 minutes, the bucket contains exactly 9 gallons of water. Well, just having a basic understanding of rates and losing half a gallon per minute, you do a little bit of multiplication to figure out that half a gallon each minute times 6 minutes. That means you would have lost 3 gallons in those 6 minutes. And then if we had 9 gallons left over after losing 3 gallons, you do a little simple adding and you realize that there were 12 gallons initially in the bucket. And just a simple side note, they didn't ask you or need you to show all your work, but I guess if they did want you to show all your work, then that should be enough. But part B specifically asks for an equation that's in point-slope form. Point-slope form is going to be on your Keystone formula sheet as this. Now, maybe I should say that it's possible that on the formula sheet, just like the wall tattoo I have, up on the wall, that there's going to be parentheses around the y minus y1. Don't be thrown off by that. I just thought I'd say that. I don't know. It's not going to really make any difference, but here's point-slope form, where in order to write an equation in this form, we essentially need to know a point and a slope. That's kind of why it's called point-slope form, because it kind of shows a point, which is going to be the x1, y1, and that would be like the point that would be on the line or whatever, and the slope would be m. So a point, well, you need to realize big time that the x variable is representing the number of minutes. So it's x minutes, and let's see here, the y variable is the number of gallons, but it's not the number of gallons that we've lost, okay? It's the number of gallons left in the bucket. So it's important to recognize the difference there and the distinction that our y variable is going to represent the number of gallons remaining in the bucket after x number of minutes. So anyway, trying to cut to the chase here. As far as a point, which is essentially an x-y pair, what we're looking for is a minutes-gallons pairing. We're looking for a certain number of minutes that pairs up with a certain number of gallons in this situation. And you could probably think of a bunch, I guess after 0 minutes there was 12 gallons, at the start. So maybe like 0, 12 would be another one. But anyway, we do know that after 6 minutes there was 9 gallons left over. So I'm going to use that as a minutes-gallons pairing and basically as our point. We also need a slope. Now you got to remember, in preparing for the Keystones, that slope and rate pretty much the same thing. So our slope is that our rate is that we're losing half a gallon every minute. I want you to realize we're losing. So it's like we're going down half a gallon every minute, which means that your slope, your rate, is going to be negative 0.5 over 1, or just negative 0.5. And then from there, I mean, now that we have a point to plug in for our, look, x1, y1, and we have a slope or a rate to plug in for our m, that's really all we need to do. And I mean, I'm essentially going to write the exact same thing because they are asking specifically for this form. Okay, so we notice again we plugged in the slope or the rate in for m. We plugged in the x coordinate of a point in for x1. We plugged in that gallons value in for y1. You know, essentially we plugged in the y coordinate for y1. You don't plug in anything for x. You don't plug in anything for y. All you need to do to plug into this form is the slope right there and the point in for there and there. Nothing in for x and y. And that's part B. Part C is also pretty simple. They just ask how many minutes does it take for the bucket to lose 7.5 gallons of water. Again, this just kind of boils down to like your basic understanding of like a rate and how like we are losing half a gallon every minute. So if we're losing half a gallon every minute, how long would it take to lose 7.5 gallons? That's essentially going to be division. You know, whether you need to write this out or not, or really think of it blatantly as like a division problem. I mean, I don't know, like you're essentially doing division. And 7.5 divided by 0.5, it's going to take 15 minutes, you know, to lose that many gallons of water at that rate. Okay? And the final question asks, what is the total number of minutes it will take for the bucket to be completely empty? First, the fancy way. The bucket being completely empty translates to y equaling what? Remember, the y variable is representing the number of gallons left in the bucket. So, being completely empty, doesn't that translate to the y value equaling 0 gallons left in the bucket? Yeah. So look, classic keystone situation where you are given an equation, or you're supposed to have an equation that involves two variables, x and y, and then they essentially tell you one of the values and ask for the other one. So, long story short, here's one way to do it, where you take the equation you have and I plug in 0 for y, and I just let this play out where I just, from there, I solve for x. Doing all this work, getting x by itself, and figuring out that the number of minutes, x, is 24. So that was the fancy way, just, like a rough overview of it anyway. But if you attempted this on your own before watching the video, which you should have, maybe you just figured out in one way or another that, okay, well, it took 6 minutes to get down to 9 gallons because of the rate, like keeping in mind what the rate of drainage is here. It took 6 minutes to get down to 9 gallons. Now, isn't it going to take another 18 minutes for that remaining 9 gallons to also drain? It's not that tough to figure out that it's going to take another 18 minutes to drain the rest of the way, and 6 minutes, 18 minutes, that's a 24 minutes. Remember, they want total. So that's that.